Good morning, everyone. Hope everyone is doing well. Cool. So, today actually we are planning to discuss about the multilinear regression, but mainly I think you all are kind of familiar about the multilinear regression, like where you have multiple features. But today's focus is actually with multiple linear regression model with interactions and with leverage, like how leverage actually influencing the model and how we can eliminate those leverage points and build a good model. Couple of things. If you are not familiar, the difference between the outlier and the leverage, there is a nice article actually on the Penn State Eberly College of Science. Excellent article for understanding point of view. But high level, an outlier is a data point whose response Y does not follow the general trend of the rest of the data. On the other hand, the data point has a high leverage if it's extreme predictor X values. So you can go through this thing, but high level I can just show you from this picture that this is kind of an example of outlier, like where all your X values are following some trend, but this particular value is not following that trend, then it's kind of an outlier. Um, this is kind of an example of a leverage where your X value is extreme compared to your other X values, other features actually. So this is kind of example of leverage, but it doesn't mean that this will impact here because this will fall on your linear function, linear graph actually. So this will not impact much, but if you have this kind of leverage, like which is not following the pattern, then this will definitely impact your model actually. And basically today we will show like how to identify this kind of leverage and how you can eliminate it and how you can make a better model. Okay, so let's start. This is the practical example. Once again, the data I took it from this place. So I gave that link by chance if you need this, but otherwise I will keep the file into my GitHub location. This is actually Florida 2000, I think 2000, yeah. So anyway, let's run this piece of code. So basically it has high level, it has these are the features. So you have the county, we have the different PM's name, president's names, and their corresponding whatever vote they've got actually. Okay. For today's work, we really don't need this pair plot, but I just show you like how to build the pair plot or how to build your correlation matrix. Just make sure that there is no null values. So all these things, if you just want to understand and you can understand what is the correlation and all those things. Cool. Let's start the actual work. So what we are planning to do, we are planning to construct a multilinear model without first without interaction terms, and the Bush column is our predictor columns in this case, and we are using all the other three as a X variable and Bush is the Y variable. Just a simple multilinear regression without any interaction. I hope you understand what interaction means. Interaction means when you have um, two values like x1, x2, then you can build one more feature which is like x1 into x2. That's interaction. Okay. So you build this model, you say, okay, my R square is this one. And I think by the time you all are kind of little bit of familiar with this summary um, results where R square is a very important factor. So R square is coming as it is high, the R square value, the model is good. So 0.87 is quite good, not that bad. And then if we check the p values, we can see gore and nadir are kind of significant, but this particular feature is not that much significant. But at this moment, we are not removing anything. We are just going to build another model with the interaction. So this is the model which is getting built with the interaction. What does it mean? You will understand very soon. So once you do the interaction, you see, first of all, your R square got increased. So what does it mean? You have all the features, but along with that you have features with the combined features, and there are combined features like this. Okay, so this is good point. Now check out of these combined features which one is significant and which one is not significant. So obviously we can see this feature is significant because the p-value is coming to 0, and the standard error is also good. So this is nice, but this one is not that good. Even this one is okay. It's not, uh, we are not considering this. Okay, so only one value we are keeping, that is this. And if you do that, then you rebuild the model once again. So let's rebuild the model once again, and you will get the value like this, which is definitely increasing. Sorry, in this case it's dropping, and that's the reason actually, because here it's a drop. Okay, so now basically we will think about this leverage versus square of residual graph. This plot will tell us, okay, you build this model, but your model performance got dropped. Let's check what is the reason behind this drop. And we saw that, okay, when we are putting this leverage versus squared residual graph, there are some points which are kind of little bit high leverage and high squared residuals also. So these points are impacting points actually. But overall, like we don't know, like maybe we can remove this all four and we can get a very better performance actually. So this is the way we have to identify the leverage versus square residual graph. And from this, if you want to identify, okay, few records, which are probably in this graph kind of is coming into this boundary. So that way we can identify first 5 rows. This second piece of code is basically identifying that rows, and it is identifying, okay, these are the unusual row information which and their index values from the data, and their leverage values, their residuals values. Okay, now once you got this information that, okay, these are the actually the observations which are kind of not following the same pattern, and they have a in this graph they are not in this group actually. So what is the ideal thing? Ideal thing is start eliminating these things one by one and check how the performance is improving. So what we thought, okay, let's remove this two first two, because these two are seems like leverage is kind of very high, and residual square is also high. So let's remove these two, and we remove these two from the data point. And immediately after data point removing, using that interaction model, same model, we ran it, and look how good the model is now. It's now 9.666. So R square is good. And don't rely just on R square. Always check the p values and check the p values. Absolutely very good p values are coming here. So statistically significant. So all the features now statistically significant, whatever data we have. So that's the way basically handle this kind of a scenario. So one thing just remember, leverage is not same as outlier, but leverage are some of the times this cause a problem. And the perfect example is in this graph. Like if your leverage is something like this, then probably it's not a problem because it's on the same line actually. Probably it's just a small problem. You're not bothered about that. But if your leverage is something like this, where your x value is completely out of this side, then it's definitely a problem. Okay, and hope I will share this code and this will help you to build other models, something similar like this way, because a lot of time we remove the outlier, but we don't think about the leverage points. So think the leverage points and that probably give you a better model. Always think about the outlier and the leverage, both the things for multiple linear regressions or linear regression problems. Remove them if they are really outlier or really leverage, remove them and build a better model. Complete code will be available. By chance, if it is not available, just email me. And if you like it, please give a thumbs up. I'm trying to build a lot more such videos so you can help the way I'm also learning. Thank you so much. Have a nice day.